Hey everyone, Michael Unger here from the MacMillan Space Centre, here again for another edition of Ask an Astronomer. And of course, we are here with our trusted astronomer, and that is Marley. Hey Marley, how's it going?
It's good. I'm enjoying the brief sunshine we have before it inevitably rains again.
And of course, we do have some geese that have shown up, some baby geese that have shown up here on site. If you are familiar with the area where we were in, there are a lot of geese, and it is springtime, and there's certainly a lot of spring geese that have shown up here in the park.
Oh, a lot of babies and a lot of droppings, but they're cute, so I guess they can get away with it for now.
Well, I wonder if these geese are as interested as.
Oh no, Michael's gone. But I was assuming he was going to ask if the geese are as interested in space news as he is, and I'm going to go probably not, because I feel like geese only focus on two things, and that is eating and being a terror to society. But until Michael gets back, I'm going to jump in to the PowerPoint and the news that I have today. So that is going to be kind of all about really two things today. And if you recognize this image or maybe have an idea of what this might be showing, you'll have an idea of what I'm going to be talking about today. So this is a global picture, an image, an artist image of the locations of the telescopes making up the Large Event Horizon Telescope collaboration and the long baselines between the telescopes. And the reason, oh, Michael's back, he's made it.
Here I am, here I'm back.
How's the geese?
The geese interrupted my flow, but I am back. What I was saying before I left, for all of you in YouTube land, if you are have any questions, this is Ask an Astronomer, so please put your questions into the chat, and we will answer all of your questions. If you're watching on Telesoptic, come on into YouTube where so you can ask your questions. But we have some stories to get to. Let's get to talking about some black holes, Marley.
Yes, so this is why I'm showing the Event Horizon Telescope image, because I'm going to be talking about all about Sag A star, the black hole that lives at the center of our Milky Way galaxy. It's called Sag A star, short for Sagittarius A, which is kind of the location in Sagittarius where it lives in the constellation Sagittarius. So this is an image of it. And it was released May 12th, early in the morning, and I was awake for it. It was 6 a.m. Pacific time, but I did it. I got up and was able to see the announcement when they released the image. And you may notice that it looks pretty similar to this one that was released of M87 star in 2019. But there are some key differences between the two black holes. Overall, Sag A star is much smaller than M87 star and much quieter. And it's a lot more, it's very inefficient at accreting the matter. M87 is much better. So less than 1% of the material within Sag A star's gravitational influence will reach the event horizon. Most of it is just ejected back out into space. This is makes Sag A star pretty dim, pretty hard to see, and it's basically on a starvation diet. I think one of the ways they explain this is that if Sag A star were a human being, it would eat 1 grain of rice every million years. So it really does not get a lot of material going inside of it, whereas M87 star gets a lot more.
So some of the things that I've been reading about this image, Marley, is that the size difference is quite considerable. So not only is it not getting a lot of food, but the actual physical size of these two black holes are very different.
No, it's very different. So this is a size comparison to emphasize the size difference. So M87 star is on the left. And if we were looking at the image, we have the Voyager 1 would be over here. Pluto's orbit would reach out here. And inside Pluto's orbit, we have a zoom in or an insert of Sag A star, where the sun's diameter is represented by that dot. And really most of the ring of light that we're seeing, the light emitted from the gas being accreted only goes out to really Mercury's orbit. So it is a very, very small supermassive black hole relative to M87 star. We usually see supermassive black holes, not see them, but anticipate them to be more so the size of Sag A star. So it's not that Sag A star is unusually small, it's just that M87 star is like incredibly big for some reason. they were also, the thing with Sag A star is that it was really, really hard to actually get the picture of because of this, not just the difference in size, but things that happen because of its incredible size difference. So it was very difficult to image because the gas around both M87 star and Sag A star go at the same speed, almost at the speed of light. But because Sag A star is much smaller, the gas completes that loop in a less amount of time than M87 star. So it only takes about a minute to orbit around Sag A star. Wow. And so the brightness and the pattern of gas changes from minute to minute. So the new tools had to be developed because for M87 star, that gas would change because it's still moving, but the brightness pattern would change, more so like days or in the order of weeks. So they could look for a long time and have a pretty stable image. And they described it in their press conference as for Sag A star trying to get an image of a puppy while it's chasing its tail. So it's just a lot of movement going on. And so they had to create a bunch of new tools to be able to get that picture.
Oh, that's really cool. So this is really why the image does look different as opposed to the Sag A star, because there is more of sort of like, it looks like energy and sort of like that all around the orbit of the black hole here, as opposed to where it's mostly on the bottom of the image in the previous black hole image.
Yeah, so the image that we have for Sag A star is actually not just like one image, it's actually an average over thousands of images that they got. So they described it as like hearing a song being played by a piano, but only certain keys at certain times. And so eventually you can, put enough pieces together and get a complete song. But in this case, they had to use the telescopes they have. Each telescope, a pair of telescopes, when you take a picture or image with them, gets you a different view of the black hole. But even then, they still had a lot of pieces missing. So they had to feed all the information they had to supercomputers and create new algorithms and stuff. And the supercomputer was able to spit out all of the images it could possibly look like. And then they compared them with the images that they did have. And so this slide is like some of the supercomputer images they were getting that were generated from the data that like filled in the gaps. So our black hole could look like any of these at different times. So they took all of these, averaged them all together, and they ended up with 4 different key groups of black hole, orientations, I guess. So you have, those are the ones on the bottom of the main image. So in 3 of them, you have those bright dots that they're not too sure exactly what they are. Some people, there's thoughts that they might be just more gases there. Some think that that gas has been Doppler shifted towards us, so it's coming towards us, so it's brighter, but they don't have enough confidence in the data to say either way why we have those bright spots. But 3 of those images have 3 of the groups have a clear ring structure with all of those bright dots, and then the 4th has no ring structure at all. And so some telescopes, some teams were getting images with a clear ring structure, and some teams were getting an image with no ring structure whatsoever. But it was that they were just getting a different view of the black hole because its gas had shifted in that time. And so the image we do have is an average of all those 4 groups put together. So it emphasizes the parts that look the same and suppresses the ones that are outliers or look very different.
Well, speaking of songs, Marley, are you familiar with Mr. Mistopheles?
From the movie Cats, yeah.
Well, that's exactly what Keith thinks that these pictures look like, a poster for Cats.
Oh, the eye, the jellicle eye. Okay, yeah. I can see it. Okay, Keith. All right. Obscure reference, but I got you.
So this is really interesting. So we now have 2 pictures of 2 different black holes. So what is this all amounting to? What new information about our black holes are we learning now?
Well, a big part of it was that we were able to, of course, reconfirm Einstein's theory of general relativity. That's, Einstein's theory predicts the size of the ring structure, how big it will be depending on the mass of the black hole. And so we did that again, which is always very exciting. And we've also now know for sure that the compact object at the center of our Milky Way is in fact a black hole. This has actually only been a theory or hypothesized because we are very hesitant to say it is something unless we have direct evidence of it. And now we have that direct visual evidence, which is always very exciting. And to have something that changes minute to minute means that we can study it and kind of see its evolution over a period of time and have a better idea of how magnetic fields and the gas interplays around the black hole, and begin to really build and solidify our theories and on how black holes work and what their environments are like.
Nice. So what are like the next big discoveries that we could possibly make?
So there's always more. I mean, the goals are, to get as many photos of black holes as we can. But in this case, like movies or animations, particularly of our black hole, are something, because it changes so often, is something that they're working on doing, as well as the interplay of magnetic fields, how black holes grow. But with all of those things, we also have to work on advancing our technology. We can't do it just yet. And so building new algorithms, testing those, working on different data sets and trying to get up to a level that will allow us to do these things, as well as studying the outbursts, which are like bright flashes of light and energy that come when matter crosses the event horizon, trying to study those more as well, are all kind of like their next steps, which is a lot of next steps, but they all kind of bounce off each other, play off each other.
Well, this is great. This has definitely been a few years coming just to get this image. This is fantastic. This was really one of the bigger news stories to come out so far. It's a nice little bit of a surprise. We didn't know this was coming out. It was nice that they gave us a heads up. We had previewed this on a previous Ask an Astronomer, but something that we have been talking a lot about here on Ask an Astronomer, and also anticipating finally getting some images, and that's with the big Webb Space Telescope. So you've got some updates for us on that.
Yes, so it is in its final stage of commissioning before Webb moves on to scientific operations. And so it's commissioning and doing final testing on its suite of scientific instruments. There's 4 of them, and each of across the instruments, there's 17 different modes they can be in. And so they have to make sure all those modes are working. And so they are working on that. You can actually follow along at their Deployment Explorer. It has this really cool graphic and links to blog posts and things about how the telescope works, what these 17 modes are in detail, and then also if they've been completed, when they're completed. To my knowledge, as of when I looked this morning, none of them have been completed just yet, but they are working on those tasks. And then science and first images can begin. So all the cool thing about Webb and a lot of space missions and stuff is that all of the projects are public knowledge. You can go and find them and see which institutions got telescope time, who the PIs are, and stuff like that. And so these are some of Webb's first science projects for cycle 1, which is how we refer to as like the first year Webb will be observing. It goes in cycles because it's not necessarily a calendar year. And there are 3 categories of observations. So that's guaranteed time observations, and those go to people who helped, or institutions, people, teams who helped develop Webb and Webb's instruments, which have about 3,800 hours allocated for guaranteed time. Early release science observations, which are for the benefit of everybody, and kind of very like catalogs and stuff like that, which have been given 500 hours, and then general observer programs. So just anybody who's applied, and they'll get, for any institution, if they get picked, they get put in general observer, and that's just about 6,000 hours of time. And so there's a bunch that I'm excited for. There's one about thermal emission from a planet orbiting a white dwarf. So looking at an exoplanet orbiting a white dwarf and looking at the heat in the infrared coming off of the planet. Investigating whether or not the turbulence from active galactic nuclei hosting galaxies suppress star formation, which is very right in my wheelhouse, something I really like. High contrast imaging of exoplanets and their systems, so actually getting photos of them. Observations of the Jovian system, so right in our neighborhood, Jupiter and its system and moons and stuff, getting images of those. The Canadian Cluster Survey on First Galaxies Ever Formed is actually one of the 2 Canadian guaranteed time observations that are on Webb's suite of investigation and science projects. And that's going to be looking at just making a huge catalog and survey of the earliest galaxies that Webb can see. And it's actually, it has a much longer title. I shortened it, but its acronym is Canucks, but without the K, which I thought was like very funny and very Canadian. And then also, are there active galactic nuclei in all ULIRGs, which is, what is it called? Ultraluminous infrared galaxies. So a lot all across Webb's, different 4 scientific, now I'm missing the word, but all of the 4 categories it's investigating. The some of the projects, like all the projects are encompassing all of them or across all of those 4, but I'm mostly excited for these ones. But there's more I'm excited for. I can't put them all in, obviously, but these are some of like the top ones.
So AGN, active galactic nuclei, what exactly is that?
So it's what we refer to as like the nucleus of a galaxy, where the supermassive black hole lives and like the environment around it is luminous, it's bright, but if it's classified as an active galactic nucleus, it's more luminous than we expect it to be. So it's very, very bright, very usually in like the X-ray. It has a lot of X-ray radiation coming off of it, more than the average galaxy. And so we would describe it as active. So often or sometimes this can be accompanied by large radio jets coming out of the center of the galaxy or the nucleus of the galaxy. So M87, has those big jets. Our black hole does not have those jets. So AGN are these very interesting galaxies, and we're not too sure why a galaxy becomes an AGN or when it stops becoming an AGN, and if that intense activity and higher than normal activity in the black hole in the nucleus environment, if it moves all the dust out, if that will suppress star formation because stars form from collapsing dust clouds, or there's theories that it excites the dust into collapsing, triggering even more star formation. So it's really this mystery of black holes in the intergalactic environment.
Okay, so the first pictures, we're hotly anticipating them, no pun intended, with the infrared space telescope. But of course, those first images are going to come out, and they are done with a purpose because, of course, there's large project, large money investment. The public is very invested in this as well. So those first images are very important to capture the attention, much like the same way when some of the first really good images from Hubble came out as well. So what possibly might we be anticipating when it comes to those first images?
So those images you're talking are called early release observations, and they are not from a scientific project or a proposal, but they are some of the first images and spectral images taken during the commissioning stage. So the stage when the telescope is still getting all of its instruments aligned and put together and testing, right? So they are those types of images, not associated necessarily with a proposal, and they're not necessarily scientific either, though they often, kind of go hand in hand. And they will include all instruments, and these are the first images that are slated to be released in early July. And from the Webb Early Release Observation Committee, they've reported saying they're intended to have immediate and dramatic appeal for a broad audience. So some examples of early release images are the Hubble ones that we know really well, from its servicing mission 4 in May 2009, which was the final servicing mission for Hubble, when they installed 2 new science instruments and upgraded the remainder of them. And so they had to show off what these new tools could do, and you get these brilliant images. You have the butterfly or the bug nebula, Stephan's quintet clash, a assortment of 100,000 stars in the core of Omega Centauri, which is a globular cluster, and a pillar of star birth from the Carina Nebula. So these very dramatic and beautiful and very awe-inspiring images. So Webb will also be doing this because we want to show off that the $10 billion was worth it. And these are it's a good working telescope. And so I have a couple candidates as to what it may be. And my number one is the Pillars of Creation, which is a very famous image. This is an image of it in visible light from Hubble. It tells a very good story of, as Webb's been described as the successor to Hubble in a way. So having the visible light image to Hubble's infrared image to Webb's infrared image is a very good story of our improvements on technology in order to better understand the universe that we have. I think one of your picks, Michael, which is my number 2, is a deep field image. So we have, Hubble's deep field that we're familiar with, which shows a lot of galaxies. And we saw Webb's ability to image galaxies after that initial alignment photo it took of that very faint star, where we saw a bunch of dim galaxies behind it. And that was only a 35-minute exposure. This Hubble deep field image, this is the ultra deep, no, this is just the deep field. No, this is ultra deep field. That was right the first time. Image was taken over just about 12 days. And so if Webb had 12 days to look at something similar, we would see much, much more galaxies in the image. So that would be another very inspiring image. And my third one is the Tarantula Nebula, which is a nebula that is in the Large Magellanic Cloud, I think, and it's very popular in astrophotography. And we know that Webb has already image the Large Magellanic Cloud as that spectacular MIRI image that came out after Webb was aligned across all instruments was part of the LMC. So this is my other contender of what Webb could show us.
Okay, so we've already got a few, perhaps some suggestions. We want your suggestions. You can email Marley, astronomer@spacecenter.ca, if you have what you think this new image is going to be. But we've already had some possibilities and questions why we might want to image something a little bit closer. So perhaps a nearby star. Is there any benefit to looking at perhaps Alpha Centauri or something even closer?
The Centauri system, I can never remember if it's Alpha or Proxima, does have an exoplanet. So that could be a benefit of looking at that, looking at that system and trying to get an image of the exoplanet possibly, but I'm not sure if Webb will be able to resolve it. It might, but that is certainly something they could do to get an image of that. I went kind of big in my thinking just because of the dramatics and the theatrics kind of these images. They're very dramatic and big, but it is possible they could look at, one of my friends suggested like the TRAPPIST system, Webb might try to get an image of. So it is very possible. There may also be multiple images. So it is possible that one, all of these could be included with a exoplanet image because they're looking over the entire two instruments that Webb has, or it could, only be exoplanets. But it's very possible and kind of likely that it would be a mix of everything across Webb's scientific objectives.
Yeah, and you mentioned before that it's also going to be looking inside of our own solar system as well. You'd mentioned the Jovian system, that's Jupiter. So what exactly are the benefits, because we have amazing pictures of our own solar system as well. What are the benefits really of looking inside of our solar system?
The benefits is that we have views of our solar system, but traditionally in the visible, a little bit in the infrared and a bit in the X-ray and ultraviolet. We don't really have as detailed of a look in the infrared, which is just provides us a different view of what's going on with the interactions in our own solar system. And we don't fully understand our own solar system and how it formed and stuff like that. And so Webb looking into our solar system, or I guess still out at it because it can't look at the inner planets, would provide a different view of what we're seeing and a different perspective on what we're looking at in our own little neighborhood.
Nice. Yeah. So that was a question from Fer Marino. Pride's got a great question about looking to see if there was technological life, perhaps on a planet. Would we be able to detect any heat signatures coming off of that planet if there was technologically advanced civilizations?
Oh, yeah. I mean, it's possible because like the infrared is in like the heat, but the reason why Webb is looking at the infrared is because for it to want to look at the very earliest galaxies, those would have emitted a lot in the ultraviolet, but because of redshifting as the universe has expanded, that ultraviolet light has shifted into the infrared. So Webb has to look at the infrared to be able to see that light that would have been emitted at very early on. So like maybe they could see technological life. It might not, they'd be pretty hot, I'd imagine, to be able to put off that much heat, but I don't know, maybe that would be very cool.
Well, this is amazing. So what you say, like, or maybe around July, we're going to start to see these images?
Yes, so I've been doing a lot of digging because I really want to know when they're coming out. And there is a conference in Stockholm, Sweden that runs from July 11th until July 15th. And it is all about the future of visible, infrared, and ultraviolet astronomy with Hubble and Webb Space Telescope. And in their little statement of what they hope to accomplish at the conference, it has second bullet point, discussions about Webb's early release observation images. And the conference ends July 15th. And so I anticipate the images will be, presented probably before July 11th, but at least by July 15th. So that puts us in mid-July. So I do think that they're following pretty closely to their early July release of these new images.
Hot release news. This is why we pay you the big bucks, Marley. You have done your homework. You have done some detective work.
Oh yeah.
There's not many, space breaking news stations on YouTube. I feel like we're really carving a niche here, so that all of you out there that are watching this, you now know that you've got the breaking news of when Marley thinks those images are going to come out.
Yes, I also thank Anna Hughes for talking me through the web documentation that I used to see if these objects would even be visible at the time that they would have likely been observed. So shout out to you, Anna. But yeah, it's been a wild ride and kind of my whole life for the past couple days.
Amazing. You are a cosmic paparazzi, so to speak.
I prefer detective. I don't need to be
cosmic detective. Awesome. Well, this is an amazing show. If we have a few more minutes for anyone in YouTube. If you have any questions for Marley about the images that are coming out, about the black hole images that came out next month. We've got 3 shows coming at you. In fact, we might even have a special guest. I'm just confirming our special guest for our next show on June 2nd. So thank you all so much. We've got so much coming at you, lots of fun activities inside the building as well. We've got some events coming up. Go to our website, spacecenter.ca, to check out all of the opening times and the tickets that you can get for the Space Center. That's all for us here for this edition of Ask an Astronomer. Marley, thank you very much. Go outside and say hello to the baby geese.
I'm not here yet. I hear them. But they're not here
they
yet.
are coming.
So
for all of you out there, we will see you in 2 weeks, 2 p.m. On June the 2nd. Take care, folks.